Here in this video, we will see a rectangular inclined surface which is immersed in water and what are the effects of water on that inclined surface. For that, we have a question here. A rectangular plane surface 3 meter wide and 4 meter deep lies in water in such a way that its plane makes an angle of 30 degree with free surface of water. Determine the total pressure and position of center of pressure when the upper edge is 2 meter below the free surface. This is the question we have. Now, from this question, I have written this data, that is, since the rectangular plane surface is 3 meter wide, so B, that is width, is 3 meter and 4 meter deep, so D is equal to 4 meter. Next, it lies in water in such a way that its plane makes an angle of 30 degree with free surface of water, so theta is 30 degree. Determine the total pressure and position of center of pressure. Total pressure means hydrostatic force F and position of center of pressure is H star when the upper edge is 2 meter below the free surface. So now, as we have read this question, we have understood that we have to calculate hydrostatic force and position of center of pressure. So let us start with the solution for this. Now here I have drawn the diagram already, that this is a rectangular plane surface which is immersed in water as it is given in the question. Here width of the rectangular surface or rectangular plane, this width is given, it is 3 meter. Next, the depth of this rectangular plane surface is also given, that is 4 meter. Now, it is said in this question that when the upper edge is 2 meter below the free surface, here if we look at this rectangular surface, this is the upper edge, so this upper edge is 2 meter below the free surface of water. This is the free surface of water and from that 2 meter distance is the upper edge. Next, here I have marked G, which indicates the centroid of this rectangular plane surface. This centroid G I have projected it here and its distance from the free surface is H bar. Inclination of the plane is given, theta is equal to 30 degree. Next, the first question is we have to find hydrostatic force and the second one is to calculate center of pressure. Now, with this diagram available, I'll say that since hydrostatic force or total pressure is given by, we have the formula F is equal to density into area into acceleration due to gravity into H bar. I'll call this as equation number 1. Now, density of water we know it is 1000, rho is equal to 1000 kg per meter cube. This value is standard for water. Area of this element we can calculate, that is, it is 3 into 4. Area we can also calculate. Now G is 9.81. H bar is the only value which we don't have here. So we need to calculate the distance of the centroid of this rectangular plate from the free surface. Now for that purpose, what we can do here is that here, since this height up to 2 meter we know, that is this much portion from free surface till this dotted line, this is 2 meter. Now I need to calculate just this remaining portion that is below the dotted line, and if I get this portion I will add it into 2 meter and I'll get h bar. So for this, what we can do here, I have projected this dotted line. Now from here also I will project a vertical line, vertical dotted line, so that we get a triangle, and that is a right angle triangle. Now I'll say that therefore from geometry of figure alongside this small triangle, I'll draw it again here, this triangle. Now since this angle is 30, so even the angle of this triangle, that is also 30 degree. So here I have 30 degree as the angle. I'll name this small triangle, it is A B C. Now if I can get the value of BC, it means I will get this height, and if I get this height, in that I will add 2 meter and h bar would be found out. So here I'll say that from the geometry of the figure alongside, since this is opposite side, opposite to 30, and this AC, the distance from here A to C, this is exactly half of the depth. Depth is 4 meter, so from here till here it is 2 meter. So this distance of the hypotenuse here, that is 2 meter, and the same value I'll write it here. So now I'll say that I'll use the formula of sine 30 degree, that is sine theta is equal to opposite upon hypotenuse, that is BC upon AC. So from this BC, it is equal to AC into sine 30. So therefore BC is AC is 2, so 2 sine 30, and finally BC value, it comes out to be, it is 1 meter. Now after getting this value BC, in that I will add 2 meter and get h bar. I hope this is understood. Now therefore h bar will be 2 meter plus BC, and that is 2 meter plus BC is 1 meter, and hence h bar comes out to be 3 meter. Now once I know h bar, I can say that also area of rectangle or rectangular plane capital A is equal to, it will be 3 meter into 4 meter, because 3 meter is the width and 4 meter is the depth. So area is 12 meter square. Now put all values in equation number 1. So hence I have F, that is hydrostatic force, is equal to, in equation 1 we have density for water is 1000, so 1000 into capital A is the area is 12, next G is 9.81, and h bar, it is 3 meter. So from this I'll get the value of F, and that comes out to be 353.17 into 10 raised to 3 Newton. This is my first answer. So I have got the value of F, that is hydrostatic force or total pressure. This is my answer number 1. Next I'll calculate center of pressure, that is center of pressure is a single point where this hydrostatic force would be acting. Since center of pressure is given by, the formula is H star is equal to, for an inclined plane surface, it is Ig into sine square theta upon Ah bar plus H bar. Now I'll keep this as equation number 2. Next, we have all the values here except Ig. Ig is the moment of inertia about the centroid for rectangular plane surface. So here, therefore, moment of inertia about centroid is given by the formula for moment of inertia of rectangular plane surface. It is BD cube by 12. So I'll put the values here. B is 3, D is 4. So BD cube by 12, and my answer of I suffix G, that is 16 meter is to 4. Now after getting Ig, I'll put all values in equation number 2 and get the value of H star. So therefore, put all values in equation number 2. So hence I'll put the values onto the next page. H star is equal to, here I have I suffix G, value is 16 into sine square theta. Theta is 30 degree given in the problem. So it is sine square 30 degree divided by A into H bar. A is 12, H bar we have calculated it is 3. So 12 into 3 plus H bar, that is 3. So from this I'll get H star as equal to 3.11 meter. Now this is my second answer. So if we look into the question, there were two unknowns we were asked, and the first one was hydrostatic force, that is hydrostatic force, or we can call it as total pressure. The value we have calculated, it was 353.17 into 10 raised to 3 Newton. Our first answer. Next, H star, that is the location of this hydrostatic force from the free surface of water. H star is 3.11 meter. Since both the values are known, now I can indicate H star onto the diagram. See, H bar is 3 meter. This value is 3 meter. So H star is 3.11 meter. It means just below H bar, I'll show it onto the diagram. Now, from free surface to the location of this point here, this I'll call it as CP, that is the center of pressure, and its value is H star is equal to 3.11 meter. So here H bar was the location of centroid G, H star is the location of center of pressure, that is at this point the hydrostatic force would be acting. So in this video we have seen how to solve a problem of an inclined plane immersed in water.